Okay, let us see what happens to this question here. Two footballers are 100 meters apart, standing facing each other. One of them hits the ball from the ground so that the ball takes off at the velocity of that at an angle 45 to the horizontal. Find the speed at which the second bowler should run towards the first bowler in order to control the ball as it touches the ground, if it runs at the instant when the ball is kicked. So here we need to just sketch. If you know the formula for getting the range and so on, then it's going to be very easy for you. So now we start by sketching, doing our sketch here. So now this man is going to kick a ball like this. Then it will reach time and then it falls. Now this player, the second player at this side B, let me say this is going to be my A, then this one is going to be B. Now if the ball touches the ground at maybe point, which point is it to use D at this point here. Now it means that now, okay, anyway, we have this one, the ball was kicked at the speed of what? 25 meters per second, and then at an angle of 45 degrees. Whenever I see this 45, it means that it's going to cover the maximum distance, anyway, as we saw. But now I'm assuming they are standing 100 meters apart. So from here up to here is 100 meters. So they are standing 100 meters apart. So if this is x distance, if from here, let me call it this, from here up to here is x distance, which you can easily get, then it means that this one has to cover, so from here, he has to cover 100 minus x so that he can meet that ball in the same time, because running at the same time. Now, it means that if you want to get the speed this man is moving, it means that because for him to move to this, we need to know the distance between this, and then we need to know the time. The time, if you know the time now, when it's going to reach this time, this point, it means that now, if you have the distance and the time, then you can get the speed. Now the time we have to reach here, it means that it's the time this ball is going to take to reach this point here. So in simple time, this one is the time of the flight, and this distance is the range. If you have this formula, then it's very easy to get. So what is our range? Let me start with the distance. Our range, which is in this time, our x, we said is given by what? Remember our range was u squared sine 2 theta the whole over b. So that's how we get the range. We saw this formula. Then to get this now, our x is going to be our u, this initial, this is always our u, is our 25 squared, then sine of 2 into 45, the whole over, we take, they give us what we use? No, then we are going to take 9.8. So our x, that distance, is going to be, so this is going to be 1. So here I'm getting 63.7755 meters. So meaning the ball is going to come up here, it's going to use x. The distance is going to be x, meaning this man has to cover. So this is the ball is going to cover from here up to here. The time it's going to cover is going to be the time of the flight. Time of the flight t is going to be, I said our time of flight is going to be 2 u sine theta the whole over g. That's the time of our flight. So now the time, so we are going to have now 2 into u, which is 25 then sine of 45, the whole over now, 9.8. So mean that now our time, the time this boy is going to take to reach that point. So there we are 150 sine 45. So here I'm getting 3.607 seconds. So now it means that this ball reaching this point is going to be 3.607 seconds, meaning this man should also run in that time. So the distance this man has to cover, so let us get the distance. Second footballer, distance to cover. Distance to cover. So distance has to cover. Our d here is going to be 100 minus x, which is going to be 100 minus 63.7755, and so this distance is going to be 36.2245 meters. So meaning this man has to cover this distance, but we know that he has, because he has to reach at the same time when this ball is arriving, so that he can control it as soon as it touches the ground. So meaning he has to use the same time for this ball is going to use to cover that. So meaning we have the time. So our time, he has to use time he has to use to cover 3.2245 meters is t equaling to 3.6077 seconds. So from there now, so our speed, this man has to move, is going to be distance over time. So which will be our distance, which is 3.2245, then over the time it has to use, which is 3.6077. So this is our speed, which will be the speed this man has to move at is going to be 10 point, okay, the distance, the speed is going to be 0.09 meters per second. Let me see this. This time was, sorry if I didn't make any mistake, maybe here. Let me see again. 50 divided by 9.8. I think, no? Square divided by 9.8. I think everything is okay. So that's the speed this man has to move to come and reach that point there. So let's remember, see you. I think we have exhausted most of the question of the projection from the ground level. Now we are going to see case 3.